Good afternoon, everyone, and welcome to the latest presentation in RSK's Technical Talk series. Today's presentation looked at the technical challenges of heating oil spills in environmental claims. Next slide, please, Mike. Our speakers today are Mike Glenn, Director of Ecologia at RSK Group company, and myself, Simon O'Rourke, Business Manager at RSK Raw. Between us, we have over 40 years combined experience in the investigation and remediation of kerosene spills. Next slide, please. All attendees, microphones are automatically muted throughout this webinar. During the presentation, you can post questions online and there'll be a Q&A session at the end of the presentation. So as many questions as possible will be answered, and those that can't be answered due to time constraints will be answered after the webinar. Shortly after the webinar, you will also receive a link to a short survey. So if you could take a few minutes to provide feedback so we can improve on future webinars, that would be much appreciated. So I'll hand you over to Mike Glenn to start today's presentation.
Thank you, Simon. Yeah, just a bit of background on who we are. So Ecologia and Raw, part of the RSK Group, and we work closely with RSK Response and Remedex as part of the RSK Environmental Response and Remediation Pod. So between us, the four companies, we've got a good spread of offices across England, Scotland and Wales. And we are ISIS accredited spill contractors and key members of the UK Spill Organisation, which is an important factor in this type of work that we'll be discussing. Just bear with me, it's like a technical problem there. Okay, so this is a brief agenda. We're in a bit of a rush, so I won't read that out, but we're going to cover environmental claims, particularly with respect to kerosene spills. So what do we mean by environmental claims? Well, it's really anything where we're dealing with an incident as part of an insurance claim, be that for a loss adjuster, an insurer, or any related profession, but particularly where we're dealing with a specific incident such as an oil spill. There are many challenges for a project manager who's tasked with one of these jobs, and some of those are quite unique to the environmental claims and domestic arena. These can include, for example, policy cover issues. If you have a buildings insurance policy, that's not necessarily going to cover you for any damage to the soil in your garden or to your neighbour's pond. So if you have an oil leak at your property, regardless of the impact, technically you may only be covered for part of the remediation that's required, or not at all. It's not our role to determine these aspects of policy cover at all, but it's important that we understand this so that we can liaise with our clients and particularly loss adjusting community. Other challenges, well, the regulatory frameworks and guidance don't always work in our favour when we're trying to balance the demands of the prompt remediation of an oil spill against sustainability considerations, for example. One topical discussion within UK Spill at the moment is the LCRM land contamination risk management guidance, which contains some quite ambiguous language in relation to new pollution incidents. Specifically here, the issue of whether a site needs to be cleaned up to pre-spill condition or whether we can implement risk-based approaches that are well established in contaminated land remediation. Clearly, cleaning up to pre-spill condition is very difficult to achieve and is not really going to help anyone or necessarily the environment. Site constraints and logistics are always at the forefront of our mind when working on residential properties, whether that be dealing with old listed buildings, which have got their own regulatory framework, access and logistics into gardens behind terraced properties, down narrow alleyways, etc. So we have to be quite inventive at times to implement remediation technologies in restricted spaces. What is unique to this environment is the expectations of the policyholder or the homeowner. Many of those will be remaining in residence while we're trying to clean up their properties. Their perception of risk can vary widely from those who can't see why we have to do anything at all, to situations where on completion, they still perceive that contamination is present at the property, even if we are unable to demonstrate that through scientific and technical testing and analysis. Sustainability is an increasing challenge for us when we're working in this environment that is, it's very much a boots on the ground operation, trying to undertake remediation. Timescales may be critical. An example would be where people are having to move into alternative accommodation while we clean up an oil spill at their property. The time to get them back into their home may be regarded as a more important factor in how we approach it than the actual carbon footprint involved. So a brief look at what is heating oil. Generally, kerosene. It's a distillation fraction that sits neatly in between diesel and petrol in the carbon chain links of the compounds involved. Kerosene contains a wide range of different aliphatic and aromatic hydrocarbons. From our perspective, when we're dealing with remediation and cleanup, excuse me, we have components that are quite volatile and with high odor, and also some of the toxicity of compounds that are present in diesel and petrol. Generally, it's the aromatic compounds within kerosene that give us the most trouble. They're relatively high solubility, particularly the BTEX compounds. They're more mobile in the environment and more chemically aggressive generally than the aliphatic compounds. Aliphatic compounds can cause some problems as well. The low molecular weight aliphatics are highly volatile. So they can be the key driver for inhalation risk when kerosene is present underneath the building footprint. I've just mentioned HVO on this slide. This is hydrogenated vegetable oil. In chemical terms, it's mostly aliphatic compounds. We'll discuss that again on the next slide. Just reference to the photo on the right, we do sometimes have policyholders who just say, you know, if we leave it, it'll just go away. Why do you need to do all of this? Well, that photo is oil that we picked up after sampling under somebody's driveway about 12 months after they'd had a kerosene leak, and it still looks fresh as a daisy, as you'd say, and you could probably run a boiler off that. So in undiluted free product form, it's not going to disappear anytime quickly. Just a bit of context on scale. A recent report provided to the government by the Offtake organisation suggested there's about 1.7 million homes that are currently reliant on kerosene for heating in the UK. And that would translate possibly to about 500,000 homes in the UK that are unlikely to be suitable for air source heat pumps and the like. HVO, which I just mentioned, is gaining recognition as a viable stopgap solution to avoid the use of fossil kerosene. But I can't see that there's going to be a widespread availability for distribution in the UK anytime very soon. So just in summary there, kerosene heating oil will be around for many years to come. And leaks are very commonplace and they can be quite complex to remediate. I'm now going to pass you back to Simon, who's going to talk a little bit more about this.
Thanks, Mike. So yeah, just to look at some of the typical causes of domestic kerosene leaks to start with. So next slide, please. So feed line failures are one of the common causes of leaks we find, whether that's oxidation of a copper pipe or rusting of a steel pipe or potentially physical impact via a garden spade or similar. I think interestingly, with these pinhole failures in the pipes, they can be tiny and they can be undetected for quite some time. So quite a significant loss of oil can occur over a long period of time before it's actually identified, again, leading to a larger scale remediation requirement. And secondly, actually, when undertaking a pressure test of a feed pipe, occasionally when there's a pinhole failure like that, it may give you a false positive, therefore suggesting there's no failure of the pipe because it's such a small failure. So always bearing in mind the potential that there is actually a leak, even if you've got a pressure test which is telling you not otherwise. Next slide, please, Mike. Plastic above ground storage tank failures, multiple reasons these can fail, whether storm damage, trees falling on them, or floods toppling them over, perhaps a material defect of the tank itself. We find expansion and contraction splits through warming days and cooler evenings on some single skin tanks. Vandalism also can be a cause. And overspills, delivery error at the time of filling the tank can obviously lead to spills to ground around the tanks as well. Next slide, please. Equally, metal tanks, rusting steel tanks, if they're not maintained well on the outside, can corrode through the steel. Equally, they can corrode from the inside out as well with condensation buildup. So it's important just to keep a regular eye on maintenance of the steel tanks to ensure that there's less likelihood of rusting occurring. Next slide, please. Fire, another failure cause. This can affect single skin and bunded double skin tanks, as shown in the bottom left photo there. There is Oftek guidance alongside the building regulations, which gives an indication of where to store tanks and to keep them protected from flammable boundaries to mitigate against that potential loss, because it could be pretty catastrophic, as you'd imagine. Next slide, please. And domestic appliance failures as well, whether that's a boiler situated internally or externally, or a cooker that's fired by oil. They all have components within them which have the potential to fail. We've historically seen quite a number of failures from braided hoses within boilers, which are a common cause for leaks. More regularly, I think I've seen Oftek engineers replacing those now during the annual services, so perhaps less likely going forward, but it has been seen as a weakness in the past. Next slide, please, Mike. So we've covered a couple of the common causes. Now we're just going to start looking through the approach that we take to understanding the risk associated with these leaks. So next slide, please, Mike. So conceptual site model, or CSM, this is common in contaminated land industry, the source pathway receptor scenario, and the same applies when we're considering how to go about managing and addressing oil spills. The important aspect of it is to evaluate the risk based on pollutant linkages between the source, the pathway and receptor, and equally ensuring that you're reassessing it and reevaluating it through the life cycle of a claim of a project to ensure that you're understanding all of the knowns and the unknowns that might be relevant. As Mike's already covered, I mean, this typically falls in line with the LCRM methodology, and the methodology does state for new pollution that CSM is applicable, although it does give warning around the risk assessment approach. But the two often go hand in hand, so it does provide some complications and extra technical challenges there. As a footnote there as well, risk assessment models are often focused around human health and controlled waters, but not necessarily with acceptance criteria derived for damage to building structures, which ultimately, in a domestic situation of a spill, is one of the key drivers for the insurance policy. Next slide. Thanks, Mike. This is typical scenario here, or typical example here of source pathways and receptors that we can find in contaminated land. We've emboldened the pathways which are more appropriate and the pollutant linkages that are more appropriate for a domestic situation, but it kind of identifies there's quite a number of potential sources, quite a number of receptors and pathways that need consideration and need good investigation to understand them through the lifespan of a claim as well. Next slide, please. So just going to look at a few of the source pathway receptors in human health to start with. So the image there showing, again, the typical scenarios of ingestion, inhalation, dermal contact around a domestic home. And noting some of the impacts can be variable with a kerosene leak. There are many different compounds within kerosene which are known to have different adverse health risks. Some shorter term, such as the headaches and dizziness. Some studies showing some longer term exposure effects as well, such as nervous damage and effects on the lungs and cardiovascular systems as well. So it's important to try and understand and ensure that the risks are known through the CSM model. And a note as well to one side is that just in the last couple of weeks, a new C4SLs have been released for naphthalene. So this is relevant now for introducing into risk assessments as well. Next slide, please, Mike. So moving on to thinking about the source pathway receptor model around controlled waters or the water environment in Scotland. We're looking at groundwater, surface water, and again, source protection zones with that as well. So from a groundwater perspective, thinking about shallow perched water to start with, that can sit in and around building structures, and often from a perspective of an environmental claim, may be a trigger with regard to the risk to a building structure itself, rather than a controlled waters aspect. So it would often get picked up via the building policy, but again, we'd be led by the loss adjusted insurers in that regard. Separately, deeper groundwater can have impacts on private abstraction boreholes or other off-site receptors, or equally onwardly to surface waters which are fed by that groundwater body. Equally, however, surface waters can be affected directly via impact from, say, drainage, or if you've got a clay material, say, below the ground or below the property, there's a chance that the oil will hit that less permeable layer and spread across that laterally rather than reaching groundwater. So although you may have a fairly impermeable ground condition below the property, doesn't mean that there's a low risk to controlled waters. So again, a thorough understanding of the local geology, the hydrogeology and hydrology is important, along with good solid investigations to understand the ground conditions and how that all interlinks into that CSM. Thinking about more specifically building structures, CSM still applies when thinking about migration around structures. Again, the type of structures and type of foundations and soil types all make a difference. So taking a strip foundation, a strip footing, they're often backfilled with more permeable material, a lovely pathway for oil to migrate around the property. Equally, if you've got different floor types, suspended floors or cavity walls, they give an opportunity for vapors to travel more freely around the property, albeit if the kerosene product itself perhaps is situated within the soils. Obviously, if the soils are more porous, there's a chance for it to travel further, possibly laterally or vertically. Equally, if it's more competent, more clay-based, then it might hold it up in the surface, but may encourage it towards those structures. Again, the fabric of the structure itself, whether it's a brick, a block, plaster, lime, etc., they have different porosities, they have different opportunities for the kerosene to migrate through that. And in around drains and services as well, more modern services are often surrounded by a bedding of pea gravel or sand, again, more permeable for the oil to track. Some older services perhaps might have a concrete surround to them, which might mitigate some travel of kerosene around those services. So again, thorough investigations, understanding your CSM in that sort of environment is important as well. Next slide, please, Mike. So just going to take a final look at some impacts to building structures that we typically find in around properties as well. So upon lifting floors, subfloor damage, these photographs show are quite typical. Maybe a damaged wrinkling plastic damp-proof membrane beneath the floor. Polystyrene type insulation seen in the bottom left and top right photos here. The kerosene effectively melts that down. So you end up with a void space under the floor, leading to collapsed floor finishes, as shown in the bottom right photo there, where the floors become sunken. So during walkover visits and site visits, finding that spring in the floor is the telltale sign that there's probably some impact and failure going on beneath the floor. Next slide, please. Staining structures, more of a visual impact than anything else, but one of the key aspects of it is it can release emission of vapors and therefore affecting human health. So whether that's staining of subfloors, again, the surface coverings once carpets, etc. are lifted, or whether it's into the visibly exposed structures above floor level where capillary action will wicket up the surfaces, again, needs to be understood and managed in that route. Next slide, please, Mike. Within the domestic environment, we often find bituminous materials as well, and kerosene as a lower end hydrocarbon acts as a solvent towards these types of materials. So damp-proof courses, perhaps wall tankings that are made from bituminous materials, adhesives under floors, perhaps under parquet flooring or under potentially asbestos-containing materials, all have an impact. And also tarmac-adam driveways, they can soften, they can degrade. So consideration around, is a surfactant treatment appropriate, or actually do we need to consider uplifting that impacted driveway? Again, all comes into the conceptual site model and understanding the risk and the impacts and the remediation solutions. Next slide, please, Mike. We often come across historic wells as well in properties, so they can be visible within gardens or perhaps even visible within cellars, or equally they can be hidden beneath floors and only become apparent once we start undertaking investigations. They can act as a secondary source of contamination. They may be a sump of oil, as shown in the bottom right photo, where kerosene has found a location to naturally rest, and also can be another point of vapors to be released into the property. So again, thinking about your live conceptual site model, understanding all of those pathways. And if you've got something that seems a bit peculiar, is it because you've got a hidden well underneath the property? And that can suddenly link things together once you identify it. Next slide, please. And finally, around the property, looking at impact to drinking water supplies. So typically this is via one of two routes, either direct migration through the groundwater into a private abstraction borehole. It's quite a challenge to return an existing abstraction borehole to a serviceable potable use afterwards. So often we're having to think about installing new investigatory boreholes around the property, modelling groundwater flows, permeabilities, understanding the best location for a new borehole to be sunk, ensuring it doesn't fall the same fate as the original. And also permeation through polyethylene pipes is commonplace as well, even with fairly minor residual contamination left in the ground. So solutions such as barrier pipes are often recommended to protect off that risk. And so I'll hand you back to Mike to carry on the next section.
Thank you, Simon. Conscious of time, so apologies if I rush this a bit. We're going to take a brief look at the application of some remediation technologies to domestic heating oil spills. Just to link that back to the conceptual model that Simon was talking about, you can remove risk by removing any part of the pollutant linkage, but for a permanent remediation solution, we're generally aiming to remove the contamination source. We can do this by a range of techniques. We're just going to look at a few examples today, but I'm going to start off just talking about hydrocarbon barrier membranes, which is where we're actually blocking the pollution pathway. So this is generally a secondary technique, which we might use where we've been unable to, to completely remove the kerosene contamination from under the footprint of a house. Obviously, if you've got contamination extending to 4 meters below somebody's living room, it's not going to be practical to excavate to that depth without probably demolishing the house, which is never going to be popular. So barrier membranes do have a role to play, and they can be applied where we've removed gross contamination, for example, in the top meter of the subsoil under a property. If there's residual contamination below this, we can install a membrane above. Very important to note that it's not just a membrane installation. What we design and put underneath the membrane is important, sometimes more important than the membrane itself. So things like air vents, telescopic vents, void layers under the membrane are a very important component of the system. And what we're aiming to do is to prevent the buildup of kerosene vapor pressure underneath the membrane and allowing that to disperse under the property. So some photographic examples here. The black matting here is a void former that goes under the membrane. Very important to pay attention to any service intrusions and services that come up through the floor. It's definitely a weak point in the installation, and you have to be very careful attention to sealing that off correctly. This shows on the right hand side, top right, shows a membrane installation ready for a concrete slab to be poured, and you can see in the very top right, those marks on the wall are where we've got telescopic air vents installed up through the cavity. The reality is often, as we see on the bottom of the screen here, these two slides on the bottom, where we're trying to install membranes where we only have access to parts of the subfloor through working underneath in the crawl space under a suspended floor, or bottom left here, a listed building where the foundations are effectively rubble, and we have to find some way of sealing a membrane the best as we can into that wall floor interface. There's no point putting in a membrane system if all the vapors are going to just appear at the edge of the room. So for these reasons, it's very important that we do some kind of integrity test to prove that the membrane installation is going to work to prevent vapor ingress into the property. We often use hydrogen tracer gas, which is pumped underneath the membrane or under the subfloor of the house, and using a very sensitive hydrogen detector, we can determine exactly where any gas may enter through the property. Typically, the problems occur in the corners of membrane installation. It's very hard to get a good seal, but these weaknesses that aren't readily identified by the normal visual or air-lance inspection. So the hydrogen test is very effective at that. So ideally, as I said, we'd like to remove the source of contamination to achieve remediation. We do a lot of building work. We supervise replacement of masonry, excavation of soils, etc. Most of the material that we dig out is sent to soil treatment centres, though we do have to be mindful that particularly older buildings may contain asbestos, and often bits of asbestos buried in soils in garden as well, in which case material would probably have to go to the landfill. But I want to just give an example of an engineered system and one example of application of chemical oxidant products. So multi-phase and soil vapor extractions are well established in commercial technology on industrial sites, but these can also be very well adapted, miniaturized, if you like, to be effective in domestic kerosene spill situation. So here we can see on the two pictures to the top left, examples where we've installed extraction pipes and lances underneath the footprint of a property or against the footings, just to the outside of a house. And on the right, some multi-phase and oil water separator systems that have been designed to go through a garden gate and sometimes even to be carried through a house and assembled, where we have a terraced house we want to set up in the back garden. So modular components can be very useful here. Key in a lot of cases is the installation of the subfloor pipe work. So we can install all the pipe work for a soil vapor extraction or multi-phase system, reconstruct the property back around it, and then people can move back in while we're treating contaminated groundwater or soil underneath the house. These systems are generally designed to run on a domestic power supply or certainly a spur off of that. So we can operate 16 amp systems or less if we need to. But with some optimization, it's quite amazing what you can achieve just on a small domestic property. Key challenges are noise disturbance, a low hum that you wouldn't notice on your average industrial estate could be a major irritation in someone's back garden. And trying to minimize the amount of site attendance, particularly in the summer when people want to enjoy their gardens, if they've got ecology or raw staff coming in every day that tend to be too happy. Remote monitoring and operation is very useful in that respect. Most of our engineered systems will implement telemetry, and it's quite advanced now, so we can achieve a lot with it. For example, we can remotely log into a system, check it's operating correctly, check the vapor recovery in different extraction lines to try and optimize the system. Importantly, all the data is logged, which means we don't have to be totally reliant on site visits and site notes to optimize the systems. We'll also get automated alerts if there's any problem, and it is useful in giving reassurance to homeowners if they're concerned that the system sounds too quiet, not working properly. We can remote in and just confirm whether the system's operating okay. Here's an example, soil vapor extraction in chalk. This was quite a significant loss of kerosene into a chalk aquifer. Major concern with public water abstraction nearby. You can see from the top photos the site logistics are less than ideal. We were limited to excavating to about 3 meters depth, even with sheet piling. But we designed and implemented a soil vapor extraction system. This operated for quite some time, about 10 months, in close liaison with the Environment Agency. These are the extracted vapor readings in parts per million from each of the SVE extraction wells. After 10 months, the system was switched off for an agreed rebound period. It's quite well established that in situ systems, when they're turned off, you can get a rebound of contamination. But after 3 months rebound and careful monitoring and switching the system back on to check, we got very little change in the soil vapor concentrations and agreed completion with the Environment Agency. Another technique that can be used quite effectively in a residential setting, if you're careful, is chemical oxidation. This is essentially use of oxidating reagents to break down or accelerate degradation of kerosene and hydrocarbons in the soil or groundwater. It's not without its difficulties, and it needs to be very carefully applied. Here's a couple of examples where we have used chemical oxidation adjacent to dwellings in people's driveways. First one was a persulfate injection. You can see after the first injection, we got quite significant decrease in TPH concentrations, but still significant dissolved phase remaining. After a second round of injection, we had a transient increase in some of the dissolved phase TPH, which is not unusual, and then a very rapid decline, which concentrations remained very low and eventually down to laboratory detection limits. On the right, this is a peroxide injection undertaken by my colleagues at RAW, and quite similar findings, more rapid depletion. So after 2 injections, they achieved almost complete removal of the kerosene in the groundwater. There are some things to be aware of when applying chemical oxidation in a domestic setting, working very close to building structures. You need to be mindful as well that chemox can really quite destroy the soil structure, so that could have an impact on foundations. It's important to monitor the oxidant levels in the groundwater to make sure the system's controlled and contained. Interestingly, I talked earlier about some of the regulatory conflicts. The waste regulatory position, RPS 215, states you must not treat groundwater in situ. That's the verbatim wording, I think. So given it takes around 4 months to deploy a full environmental permit, that doesn't really help in deciding to use chemical oxidation for a fairly urgent oil spill situation, and perhaps needs a bit more clarification. So all I'd say is before undertaking any chemical oxidation treatment of groundwater, there needs to be very careful dialogue and agreement with the regulator. Now, I wanted to talk a bit about validation, but I'm very conscious of time. So just quickly, I'll just state that indoor air validation is sometimes quite tricky. We use a PID a lot, photoionization detector. It has its limitations in sensitivity and the fact that it doesn't discriminate between different compounds. So it's really a total organic vapor reading. To get down to the kind of levels we need for validation, we use desorption tubes and GCMS analysis. And we're looking at 2 aspects there. One is a total kerosene range TPH of 1 milligram per cubic meter in the indoor air, but also risk-based targets for individual compounds and grouped hydrocarbon fractions. So we'll end up with data something like this, where we can compare against gas screening values for the different BTEX compounds and carbon fractions. I'm just going to rush over that for now. So before we wrap up, I just want to mention the need for innovation. We wouldn't have got to this point where we are in the oil spill cleanup community without innovation. And there's still a need for it, but I think where previously the driver was efficacy and cost, there's now a key driver, a key need for people to be innovative in looking at sustainability. Anything that can reduce the amount of waste disposal materials required on a job, amount of travel, haulage, will have a great impact on the overall carbon footprint of the project. In the right application, in situ on-site treatments that we just looked at can really improve the sustainability of the work, but there is some regulatory conflict, as we mentioned earlier with LCRM. that we hope we'll get better clarification on that in months to come. I just want to give one quick example before we wrap up of the kind of way we're thinking. This was in situ brick heating. So we had a complex structural pillar in a house. You can see the bricks there, which have got a nice sculpted curve on them. And also the structural engineer did not want that column to come out. It was quite complex. And we implemented a safe heating system where we were able to keep that brick pillar in situ and able to heat the bricks up to around 80 degrees C on a low voltage system. Ran it for about 6 weeks, and on completion, we had no detectable odor at all from that brick column, and PID readings into the bricks of less than 0.5 ppm. I haven't done all the calculations, but the 190 kilowatts of electricity, I think, would probably work out quite favorably when you compare the amount of waste disposal, structural engineers' visits, and builders' driving, travel time, etc., that would have been involved in removing that column. So it's just one quick example. But yeah, our drive towards net zero is going to require all people working in this field to continue to be looking for some innovative new ideas. So that's all we do have time for. I'm going to pass you back to Simon now, who's going to take any questions.
Great, thanks, Mike. Thanks for that. Yeah, so just as a reminder for anybody that wants to ask a question, we've still got time, about 9–10 minutes to cover any questions off. So feel free to add any into the Q&A box in the control panel, and we'll work through them. So I've had a couple come in, Mike, already. I'll start with the first one here, which is it possible to differentiate between different contaminants in air sampling? Do you want to take that one on, Mike?
Yes, yeah, it's certainly possible, and it is needed. I did briefly show one of our air validation spreadsheets earlier, where we're looking at all the different carbon bandings. But yeah, with GCMS, you can identify individual compounds in the air, and that is needed. And sometimes we'll sample underneath the property. For example, we'll take air samples underneath the property and inside the rooms where we've been dealing with a spill that's under the floor, and we can compare the compounds in the air vapor in the void under the house and in the room. Also, we have a look at air fresheners, plug-in air fresheners, and these little fragrance sticks that you get can cause quite a problem for us, because a lot of the compounds in there are common to kerosene. So we can compare the GCMS traces that we're picking up from the known contamination with those from the fragrance sticks, and sometimes that can solve those problems. So yes, it can be done.
Great, thanks. Second question, are there any known structural impacts to building materials? I'll field that one, as I covered off some of that section in the presentation. I mean, ultimately, from my experience of seeing them on site, beyond the impacts we've discussed already, which is sort of the visual impacts, the staining and the vapors associated, in terms of, say, bricks and blocks or similar, there's not known to be any physical degradation of those materials per se from the kerosene itself. There is a potential that sort of an immature concrete could become affected, especially if there's any sort of fatty acid content within the oils themselves. But from a kerosene point of view, it's very unusual to see a physical breakdown of the contamination of the building structure, the building fabric itself, other than the sort of bituminous and that sort of material that we looked at. Another couple of questions coming in, Mike. Can the property owner be prosecuted for these leaks? Do you want to take that one, Mike?
Yes, they could. They could be. It hardly ever happens. yes, they can. I mean, the basic principle it still applies regardless of what regulation comes in. Polluter pays. It is possible. We have had cases where both ourselves and loss adjusters and insurers have been emphasising to policyholders that they have liabilities, and particularly where the groundwater is involved, that work needs to be carried out, and you get the unusual situation where the insurance companies are wanting to spend money and the policyholder doesn't want it spent. So yes, in principle, yes, it hardly ever happens.
I think I'd say as well that homeowners, I guess, or policyholders especially, by reporting it as soon as possible to their insurance company or broker or similar, to demonstrate that they're doing as much as they practically can, stemming a leak as well if that's feasible, or isolating off a leak from a tank, for instance. If they can demonstrate that they've done as much as they're possible, then hopefully that would go in their favour from that regard. But as you say, Mike, it doesn't seem to happen commonly. Another question that we've got is, what do you do with liquids that you extract? So there's multiple routes that we can go with that. If it's liquids in terms of oil product within wells, for instance, or in boreholes, then we'll look, if possible, to install a pump and treat system onto the site, or as part of the multi-phase extraction, extract those liquids, separate them on site in situ, in line with the correct agreements with the regulators, and then discharge off any treated water, obviously, on site, and we may be left with the remaining residual kerosene, which then often gets removed from site for off-site disposal or off-site treatment occasionally. Anything to add to that, Mike?
No, where we have significant amount of free product recovered, the neat oil, if you like, then that can be sent for reprocessing and reuse. Yeah, we use activated carbon filters a lot for dissolved phase and residual oils. Yeah, generally we're not recovering large volumes of free oil, if you like. It tends to be dissolved phase contamination that we're picking up in liquid form, apart from in the early stages when we may get a fair bit of free oil for recovery.
Great, thanks. Another question here. Is bioremediation a known option for remediation in a domestic setting? Do you want to take that one, Mike?
Yeah, bioremediation very much so, and a lot of people use it. It is my background originally, so I should be an advocate of bioremediation. I'm actually a bit of a skeptic. There are a lot of products out there, and kerosene is largely biodegradable, but if the setting isn't engineered for that to take place, applying bacteria on their own is not going to achieve a huge amount. If you can't disperse the bacteria through the soil and nutrients and get them the oxygen, they're not going to do very much. So yes, bioremediation can work, but just applying a product into the ground is not necessarily going to achieve a huge amount.
Right. I think we've got time probably for one more question. So we've got one here. You mentioned single skin tanks. Are they allowed anymore? This does vary a little bit regulation-wise as to whether it's a domestic setting, commercial setting, and actually which country you're in as well. Broadly speaking, best practice is to install bunded tanks rather than single skin tanks where possible. And there is guidance again via Offtech and building regulations which state within specific situations, i.e. proximity to open drains, things like that, that it must be a bunded tank. From a commercial setting, I believe they've all been ruled out now. There was a grace period where you could have them left in situ as a single skin tank up to the grace period, and then they have to be replaced. But again, with domestic situations, I believe that the majority now are bunded or should be bunded, and it's best practice that's the case. Mike, anything to add on that?
No, I would need to check the latest guidance, but certainly not advisable.
No, indeed. Great. Okay. Well, if anyone else has anything else they want to ask, or questions that might spring to mind afterwards, our contact details are both there. So feel free to drop us an email, and we'll come back to you with responses as we need. Otherwise, just like to thank you all for joining today. Do keep an eye out for that survey that will come to you in about an hour or so into your emails. I'd be grateful for any feedback on that. And otherwise, all have a really good afternoon. Thanks very much.
Thanks, everybody. Thank you.